In this video, we will discuss about types of limits. Left hand limit, right hand limit. In the previous video, we have taken an example of the function f of x equals x square minus 4 by x minus 2. In this function, if we put the value x is equal to 2 directly, we get 0 by 0. This form is known as indeterminate form. This is not exact. Limit x approaching to 2 f of x equals limit x approaching to 2, the value of the function is x square minus 4 by x minus 2. X square minus 4 by x minus 2 equals 4 can be written as 2 square. So x square minus 2 square by x minus 2. Limit x approaching to 2, a square minus b square equal to a plus b into a minus b. X square minus a square equals x plus a into x minus a. Similarly, x square minus 2 square equals x plus 2 into x minus 2. So this can be factorized as limit x approaching to 2, x plus 2 into x minus 2 by x minus 2. These x minus 2 get cancelled. Then limit x approaching to 2, x plus 2 equals 2 plus 2. That is equal to 4. As x approaching to 2, f of x approaching to 4. X approaching to 2, f of x approaching to 4. X approaching to 2 means in two different ways, from the left side or from the right side. To understand about that example, refer the previous video. I have provided the link in the description and comment box. There are two types of limits, left hand limit and right hand limit. And what is left hand limit? If the x value is reaching to 2 from the left hand side, we call it as left hand limit. This is a table. These are x values and this is a f of x values. Then this x values is approaching to 2 from left side. That is known as left hand limit. Similarly, what do you mean by right hand limit? If the x value is approaching to 2 from right side, we call it as right hand limit. This is our x, this is a 2. If x is equal to 2, we get 0 by 0. This is indeterminate form. If x value is approaching to 2 from left side, we call it as left hand limit. And x value is approaching to 2 from right side, it is called right hand limit. For the function f of x equal to x square minus 4 by x minus 2 at x is equal to 2. Let's take the same table which you have taken in the previous video. This is that table. These are x values. These are f of x values. This is what happened when x is equal to 2. When x is equal to 2, f of x becomes 0 by 0. That form is known as indeterminate form. We put different value for x, that is 1, 1.5, 1.6, etc. Then we get different values of f of x. If we put the value x is equal to 2, at that time we will get indeterminate form. That means 0 by 0 form. We will get the answer other than indeterminate form only if we put the values other than 2 but near to. Near to means from the LHS or from the RHS. Is it clear? Now listen, this is a table showing x and f of x. We can observe from LHS, the x value is approaching to which value? Approaching to 2 from LHS. If 1.999 is very close to 2, so x value is approaching to 2 from LHS. At that time, f of x approaching to 3.999. That is very close to 4. As x value is approaching to 2, f of x value is approaching to 4. Now check the left side values of 2 are less than 2. These all are the left side values of 2. These all are less than 2. So left hand limit are indicating a negative sign. So we have noted left hand limit as limit x approaching to 2 minus f of x. This is the notation for left hand limit. This minus sign indicates that x approaching to 2 from left hand side. In the same way, from RHS as x approaching to 2 from RHS, at that time f of x approaching to 4. 4.001 is very close to 4. 2.001 is very close to 2. So x approaching to 2 from RHS, f of x approaching to 4. These all are called right side values of 2. So right hand limit are indicating by a positive sign. So that positive sign indicate that x approaching to 2 from right side. So the notation limit x approaching to 2 plus f of x. This is the notation for right hand limit. This plus sign indicates that x approaching to 2 from right hand side. This is the notation for left hand limit, and this is the notation for right hand limit. Limit x approaching to 2 minus f of x is the notation for left hand limit. Limit x approaching to 2 plus f of x is the notation for right hand limit. The x values, f of x values, this is the x value when x is equal to 2, f of x becomes 0 by 0, that is known as indeterminate form. These all are the values left to 2. These are the right hand side values of 2. These all values are negative. These all values are positive. Means these all values are less than 2. These all values are greater than 2. These all values are less than 2. So we indicate by a negative sign. These all values are greater than 2. So we indicate by a positive sign. So the notation for left hand limit is limit x approaching to 2 minus f of x. And the notation for right hand limit as limit x approaching to 2 plus f of x. Is it clear? Now again we observe the table from LHS. The difference, this is nothing but our x. X is equal to 2. The difference between 2 and 1.999. The difference between these two is 0.001. This difference is very small. Is it clear? So very 0.001 is a very small number. This difference we call it as our h. Difference is we call it as h. Similarly, difference between 2 and 1.9. 2 and 1.9 is 0.1. This is also a very small number. Difference between 2 and 1.8 is 0.2, etc. Difference between 2 and 1 is 1. Is it clear? This is our x, and difference between these two, difference between 2 and the other values, we call it as h. Is it clear? Then observe from RHS, right hand side. In the same way, the difference between 2 and 2.001. What is the difference? 0.001. Difference between 2 and 2.001. This 0.01, these all values we call it as h. Difference between 2 and 2.1. 0.1. These all differences are very small number, very small differences between x and these values. Is it clear? 2 and 2.2 is 0.2, etc. Difference between 2 and 3 is 1. These all differences are very small. In both the cases, the difference is very small. We have taken this difference value as h. 2 is nothing but Rx. As x value comes near 2, h value comes near 0.001 is very close to which value? 0. As x value comes near 2, at that time h value comes near 0. Similarly, from the right side, x value comes near 2, h value comes near 0. 2.001 is very close to 2 and 0.001 is very close to 0. In both the cases, x value comes near 2, h value comes almost equal to 0. As x approaching to 2, h approaching to 0. X approaching to 2, h approaching to 0 in both the cases. So final conclusion is that as x approaching to 2, at that time h approaching to 0. Is it clear? X approaching to 2 in two different ways. That is both from left hand side and right hand side. From left hand side, x approaching to 2 minus h approaching to 0. This minus sign indicates that x approaching to 2 from left hand side. From RHS we observe that x approaching to 2 plus h approaching to 0. This plus sign indicates that x approaching to 2 from right side. In both the cases, x approaching to 2, h approaching to 0. X minus h represent the left side values of 2. Look, 2 minus 0.001 gives 1.999. 2 minus 0.1 gives 1.9. X minus h represent the LHS values of 2. That means x minus h represent the left hand side values of 2. That is 1, 1.5, 1.6, etc. up to 1.999. Then what is 2? This is our x. Right side values 2 plus 0.001 gives 2.001. 2 plus 0.1 gives 2.1, etc. up to 2 plus 3 gives, etc. up to 2 plus 1 gives 3. So x plus h value represent RHS values of 2. These all are x plus h. Then we observe the table from LHS. X minus h represent the LHS values of 2 and x plus h represent RHS values of 2. In general, limit x approaching to a minus f of x is the left hand limit of f of x at x is equal to a. Limit x approaching to a plus f of x is the right hand limit of f of x at x is equal to a. This is our x and the difference we call it as h. X minus h are the left side values of 2 and x plus h are the right side values of 2. As x approaching to 2, at that time h, this difference value h approaching to 0. Is it clear? Limit x approaching to a minus f of x is equal to limit h approaching to 0 f of x minus h. That we observe from the table. X approaching to a from LHS, at that time h approaching to 0. Is it clear? That x is nothing but x minus h. From the right side, limit x approaching to a plus f of x equals limit h approaching to 0 f of x plus h. This a plus indicates that x approaching to a from right side. We know that x approaching to a from the right side, at that time h approaching to 0, x is nothing but our x plus h. That we observe from the table. We clear it from the table. As the x value reaches to 2 from LHS, what about the h value? H value reaches to 0. That we discussed earlier. X is mathematically we write it as x is equal to x minus h. X and x minus h values are same. That we discussed earlier. As x approaching to a means a equals a minus h. A get cancelled. So minus h is equal to 0. That means h approaching to 0. That we mathematically we write like this. X is equal to a plus h. X approaching to a means we have to replace x by a. The equation becomes a equals a plus h. So a and a get cancelled. Then h is equal to 0. That means h approaching to 0. As the x value reaches to 2 from right side, h value reaches to 0. So the left hand limit, we write it as limit x approaching to a minus f of x equals limit h approaching to 0 f of x minus h. Limit x approaching to a plus f of x equals limit h approaching to 0 f of x plus h. This is the representation of left hand limit and this is the representation of right hand limit. X approaching to a minus means x approaching to a from left side. X approaching to a plus means x approaching to a from right side. H approaching to 0 means x approaching to a from left side. At that time, we earlier see in the table h approaching to 0. Similarly, here also, if the left hand limit is equal to right hand limit, that means the limit exists. Then only we say that the limit exists. If LHS is equal to RHS, that means the limit exists. Thank you.